and I'm introducing now the next speaker. So our next speaker is Ahmad Fayyaz from the Chair of Energy Network Technology at the Modern University of Leoben, the group of Professor Thomas Kienberger. Ahmad also is a doctorate had already done his doctorate already, and his talk presents the AI-based forecasting methods for industrial energy systems, focusing on the 24-hour ahead load forecasting with long short-term memory models, and on the transition from residual load forecasting towards industrial demand forecasting. Ahmad, the stage would be yours, and I also ask you to stay within the time frame a little bit.
Yes. Thank you, everybody. So I do my best to be on time. So as a short introduction, I'm from Technical University of Leoben. My name is Ahmad Fayyaz. Bakhsh. I'm in the office next to Andreas. And as far as I'm loud, I think he can hear me without listening directly to the meetings. So today we're going to discuss my forecasting model through the friendly charge. And I'm not sure if you can see my screen. Can you?
Yes, it's well visible.
Okay. Yeah, thank you. So I'm going to discuss my forecasting method by LSTM, as I just wanted to pay your attention to the fact that my work was forecasting the residual load in low voltage grid, distribution grid, and at the end, we're going to talk about the transition from this method to the industry, the same as what Florian said. So my main goal was to forecast day-ahead residual load to control the power of the EV chargers. We wanted to see the available capacities, so having a robust model was of actual value. So we tested, we constructed our model, the LSTM, and finally we tested it to see whether or not this is a good model. We constructed other models and compared it. So today we're going to discuss mostly on LSTM, and the rest of the models can be found on our publication. So like every forecasting model, our methodology contains three parts. We start from data preparation, like everyone who is working with the data, actual data, especially in the I think even in this industry, for me, it was the same. And when you work with the data, there are lots of missed data and the data out of the reality. So we had to clean them, three genomic data that we discussed them a bit later, and we set new variables like the dummy variables. The model training was the second step, where we used hyperparameter optimizer to have our hyperparameter optimum, and at the end the forecasting that contain the error metrics and the visual data to see sometimes the error says good, and in terms of visual for some purposes like peak catching, so having both of them are so important. So in terms of the data study and management, our work contained two parts. First, demand forecasting, and the second one was residual load. We're going to discuss about the residual load, but to compare it quickly, for the demand, we had our paper, and we compare it with other models, and it's available and online. And to compare them is in terms of the inputs. For instance, when we talk about the demand, we'll care mostly about the temperature and when people they need energy. But when we talk about the residual load, it means we need some data regarding the PV generation, such as the irradiation. So as the input, here the inputs are the inputs related to residual load forecasting, temperature, wind, and global horizontal irradiation as the inputs that are not only good, not only needed to forecast the residual load and PV generation, but also it can give us some insight about the demand of the people. So it means not only during the PV generation, but also out of this range, we can have good insight by this input. The historical data, like most of the models, sine and cosine, they know day of the week and hour of the day. And the reason was the periodic nature of day of the week and hour of the day. We wanted to get rid of it, so we used the rich numeric data. So dummy variables that we're going to discuss it later in detail. So for the model properties, we use randomized search cross-validation as a hyperparameter optimizer for different parts of LSTM, activation function, dropout rate. So it's used the combination of this hyperparameter in a randomized way to give us finally the most optimum hyperparameters. So what's the dummy variables? We discussed earlier that we have it as an input. The dummy variable itself is not as important as the logic behind it. So to the common dummy variables that you can see everywhere is the separation between on-peak and off-peak. Sometimes it comes with different season. We say in this month, based on the data set that we have monthly, we measure the we say whether or not we are on peak. So simply we add one column as dummy. So in the but when we want to be more advanced in statistics, they use categorical dummy variables that instead of putting 0 and 1, we put as much as we want. We levelize it like from 0 to 20. This is quite better for every study, for most of the study, I would say, because when we say from, for example, the peak is 150 kilowatts, in case we have the threshold like 100, and we separate the 100 to 150 as on peak and the rest off peak, it means we are counting like minus 50 and 0 and 70 and exactly, or yeah, it's just below the threshold, just 0, and we just counting them the same. But categorical dummy variables can get rid of this. So we use a small AI inside our code, inside LSTM, for data as data processing. And simply we did the things that we did. We checked our data. We saw that our data is between minus 65 and 88. So we said, let's just put it to minus 72 and 88 to 95. So we made it in 16 levels, this dummy. It means like from minus 72 to 60, if this one interval or one residual load is between minus 72 and 60, put 0. If it's between 60 to minus 47, put 1, and all the way to 16, which is the highest. So, this is the basic of forecasting. When you say we have this input, it means that we have it for the day of the forecasting. We can't say, okay, the dummy variables, when we talk, for example, the monthly, it's obvious. We say, for instance, we have 96 steps of 15 minutes of the day. If it's month 1, put this. If it's month 2, put this, and so on. But the things that we are doing is for every specific day. So every day has its own dummy variables. So when we say, let me come just back. When we say we have different values, different levels, it means day ahead we have this. So what we did, we came one step back and we made importance study to see the importance of all inputs, to see which input has the highest influence in our forecasting. So based on the extreme gradient boost model, we found out that global horizontal irradiation with 53% has the highest importance. It means that in terms of catching the PV peaks or the pattern itself, global horizontal irradiation is more important than any other input. In this case, we said, so we can make the data processing a bit smart, where this global horizontal irradiation can find out the pattern for us. So we separated the days simply in weekdays, Saturday, Sunday, and holidays. We said for weekdays, for the day of the forecasting, we have a look at the last 15 similar days. So it means the last 15 weekdays. So we look at them and we grab the day that has the highest global horizontal irradiation similarity to that day. In case there is no similarity, we simply get the average of 3 days, 3 most similar days. Sorry. So for this similarity, and which is now is even more advanced, and we are working on every hour. It was simply we take the 96th step of the dummy that we explained as peak level, and we put it for the day we want to forecast. For the Saturday, Sunday, and holiday, we did the same, but for the last for similar day type, because when it comes to Saturday or Sunday, when we want to talk, when we say, okay, last 15 same day type, it's going to be like months and months, which is not really good with reality. And the holiday, we count it different. So here you can see the 10 days of the testing date. You can see here in the above, I said that we have here we have holidays separated. Here is when we separate the holidays. The 15th of August in Austria was a holiday. So when we count it separately, it learned really badly. But when we counted that day, like a Sunday, it could catch the pattern. The interesting part of this system is that you can see the Sunday, which is the most critical day, was caught so nicely. So so this was the result, the testing data. Now we want to move from residual load to industrial demand. So how can we use this model? So the targets are different here. Here we have residual load, and for the industry, usually we need active power demand. The main driver of the residual load, as we discussed, was global horizontal irradiation. Here we have the production schedule. When we have this production schedule, and based on that one, we can have the industrial forecasting model robust. The profile shape is like weather, which is like mostly the PV production can have the direct influence on the residual load, but here is step changes. like this is the thing that you can see here in as industrial profile is just something that we found from other studies. So the signs is that residual load can go negative, and for the industrial demand is always positive. This means a lot in terms of the LSTM structure. It can change the structure. It can change the scalars, and this will be done after having the data. So the decision that we have was the hosting capacity for electrical vehicle, and here is for peak shaving to have the data not above the contracted threshold or contracted capacity, and the tariff as well. So simply, if we want to talk about the inputs, the importance of the inputs, global horizontal irradiation, and the day before residual load play the most important role in the residual load forecasting, at least for the residential grid. But when it comes to industry, production schedule, shift calendar, and the process flags also are the most important factors. So the model adaptation, when we talk about the residential grid, we talk about the historical data, time, and weather data, and also dummy variables. And for the industrial, when we talk the shift calendar, the production plant, and the lags, like the last days, like 1, 2, or 3 days before load profiles or demand profiles can be of actual values. So the looking back in the our current model, we just looked at the last 24 hours, which is so typical because every day we have a pattern that can be detected. Every day can be changed, sorry. But when it comes to industry, we need to extend this look back to 1 week, and this one can change every week. So here, where the value is, here is for the peak shaving. The flexible load scheduling can be done if we have this forecast, I mean, robust forecast, and the market and balancing is, it comes through this process as well. So at the end, we want to talk about the challenges and data. Like everybody of you, I think when we talk about the data and we talk about with project partners about the data, is the most critical, at least for me. And when we want to have this industrial forecasting done, there are some challenges we are facing. The first is step changes and non-linearity. For this reason, we have a look at the last week instead of the last day for the looking back as a looking back process. So and in one time, we can go from 0 to maximum power, for instance, when we have a furnace in the system. So the process specific behavior. So there are, if we have different plants, every plant has its own pattern. So having one model for all of them can be a bit weak. So per site training would be so important. For instance, when it comes to cooling, and heating the plant itself when it's hot, when it's cold. So we need heating and cooling. When it comes to these ones, we need at least not the process itself, also for inside the company or the plant for the workers there as well, for their heating and cooling as well. So different plants, different purposes, different models should be trained. So because when there is error in the residential residual load, that one is not as costly as when it comes to industry. One missed peak can destroy our year of saving. So and also we need a good data cleaning and also improving the data. Sometimes we don't have data as good as when it comes to residential residual load. So data augmentation, data cleaning also have more power here. So I try to be as quick as possible. If you have any question, please ask me. I think, Andreas, you heard me. You didn't need any.
Thank you very much for this interesting talk, Ahmad.
Yeah, thank you very much, Ahmed, for
Thank
this
you.
interesting presentation. I know how it's challenging.
Thanks to you for listening.
Yeah, we at Natural Resources Canada are working on different forecasting tasks, and it's the forecasting approach. I mean, it's really one of the challenging tasks. So I have one question here. It's related to these dummy variables. Usually we are selecting or we are introducing these dummy variables when we need to capture special events, regime changes in the data, and some seasonal effects. But we should be like very careful, because sometimes these variables, these dummy variables, can be potential cause of overfitting or even biasing in the data. So did you face any kind of challenges when you add or play with these kind of variables? I mean, what is the rule that you select the right number of dummy variables? And can you give
actually, this is so interesting question. Thank you, Ragib or Ahmed. Which one is correct?
Ahmed, yeah.
Ahmed. So we have at least the same name. So thanks for your question. Actually, this is so critical part when it comes to forecasting. So when you want to the most important factor when it comes to forecasting the day ahead residual load or the demand, we want to catch the peak. The peak, they are in two parts, whether it's in demand or generation. Here for our forecast, for our grid, the most critical part comes when the PV is on, when the PV generation is too high. Because the overvoltage here, most of the people, it was my bad luck that most of the consumer that we have in the grid that I'm studying have PV. And during the day, when the PV generation is too high, the voltage can go crazy and we can face problem. And this one, and why this was why we had the dummy variables. But in terms of how, whether or not we faced problems, since the 1st of February, our data are online in the server, and forecasting and actual data, both of them are seen on the Grafana. And I'm sorry I can't show anything because it's for the it's a bit confidential. So and the results were surprisingly good, even during the time when it comes to March to April, when there is too much complexity in catching the patterns. And for this, and now I would like to say how we selected these 15 days. That we went through different days to have a look at. So these 15 days, it was 30 days. And it was 5 days as well. So all of them led us to select 15 days because it has the best output.
Okay. I think we should have like further discussion if you are available. I'm curious really to
Yeah, of course. It would
know
be
that.
my pleasure.
Thank you very much.
Yeah, thanks to you.
Well, that's awesome, and that is the spirit of this international collaboration, if you find now that you have a lot to talk about. Are there any more questions from the audience members? I would have one more question, and then we can transition, I think, to the fourth talk. So my question is how you're planning to deal with uncertainty of the prediction. So far it seemed to have mostly deterministic predictions, but as you noted, like one missed peak means a lot. So are you also planning to go into some stochastic predictions and how to weigh this? What's your plan there?
Actually, as far as we don't have data set in industrial, as far as we don't have industrial data set to have a look and deal with it, I don't have any feelings so far. Of course, these plans that we get from the industrial partners, we can have a look and finally make uncertainties calculation and study. But so far, our focus was on residential forecasting, and unfortunately, we didn't have that data set. For this reason, we didn't make any. I was not there to talk about the dummy variables in industry because we didn't have that data set so far.
Okay, thank you very much.